So a pointer is basically just a type of variable that holds a memory location. So I'm going to write that down. So a pointer is a variable that holds a memory location. And one way that you can think of this is it's called a pointer because it's pointing to data that you have. It can point to data that you have stored in a memory location. So for instance, let's say that we have a memory location with number. So we have, let's not write the variable name. Let's say that we have a memory location and we have 20 stored in that memory location. If we have a pointer, we can have a pointer that's pointing at that memory location. So remember this, like let's say that we have int number. Did you say reference variable? Okay. Let's say that we have a, well, so remember, maybe I'll just write a function. So let's say that we have a function that's void, and I'll just call it example. And remember, if we had a reference variable, number, and we call this function, then let's say this is the main function here. So we call this function example, and we send it number. Then we can directly change. So this function, and let's say that this number is equal, say this is equal to 20. If we change the value of this variable down here, so let's say we set it equal to 30 in this function. Before we call the function, number is equal to 20. After we call the function, number is going to be equal to 30. The two ways this is one way that we've already used memory addresses to work with data. So the first is reference variables. The array is, well, let's say we pass an array to a function. So the name of the array is the memory location of the first element in the array. So I'm going to put, I'm just going to put array to function. So these are two ways that we've already kind of seen this idea of where we're using memory locations with data. Pointer variables are really similar to reference variables, but they're not exactly the same. So I'm just going to put that pointer variables are similar to reference variables. One of the main differences is, well, pointer variables work at a lower level, which basically means that they require more work. So pointer variables work at a lower level. And basically what that means is that they require more coding on your part to use them. To use pointer variables, and we're going to see an example of this, but basically what you need to do is you write code that gets the memory location. So we've already seen how to do that. If we put this ampersand in front of our variable, that basically returns the memory location of that variable. So we've seen how to do that. So to work with pointer variables, first we write code that we use to get the memory location, and then we assign that address to a pointer variable. So remember, a pointer variable holds a memory location. And so we're going to look at some code with this in a minute, but before we do that, I wanted to list some reasons for why we would even want to use pointer variables, because right now it looks like, well, why don't we just use reference variables? Well, we need pointer variables for a few things that one of them we're going to get to in this class, so that's dynamic memory allocation. And dynamic memory allocation just means that we're allocating memory while the program's running. With arrays, we had to assign the length of the array before you could dynamically allocate that memory once you get the file and see how large it is. Or if you're, say, having the user enter data, you might not know how much data they're going to enter. Like, are they going to put in 20 scores, 500 scores, 1,000 scores? So you can use dynamic memory allocation to allocate memory while the program's running, so you don't need to know ahead of time how much memory you're going to need. So we need pointers for that. We need pointers for a few other things that you're going to do in the 1410 class once you get, for those of you who are taking that class. But you need, let's see, so you need pointer variables for creating and working with objects. And this is chapter 13, 14, and 15, so you'll get to that later. So let's look at how to declare a pointer. So I'm just going to put declare a pointer. So what we do is, let's say that we want a pointer that's pointing at an integer. We just put the star in front of our variable. And what this is saying is that this pointer, this is the type. So this is just like every other variable we've defined. So we have the type and the name. And this is specifically saying that this pointer can hold an address for an integer. So this pointer can hold an address of an integer data type. And one thing I want to mention is we can put the star either right next to the type, or so you can put it where you want. Different programmers like using it just so whatever you feel most comfortable with, you can use it either way. And you can declare any type. So for instance, you can have a string, and then this is just going to have a star. Basically what you're saying with the string is that that this pointer is pointing at an address that can hold a string data type. All right. So one thing that's really good practice is when you when you declare pointers, it's good to initialize them to an address when they're declared. And the reason why is because if you have an uninitialized pointer, it can affect memory locations that you might not be expecting it to affect. So for instance, like when we're initializing, or when we declare these that I have written down already, they're pointing at some address, and we haven't initialized them to an address yet, so they might just have some random address that is unknown, and that's not a good thing. So it's really good practice to initialize pointers to an address when you declare them. And so there's a few ways you can do that. First of all, you can set it to the address that you want. Or if you don't know the address right away, which a lot of times you might not know, you can initialize it to what's called the null pointer. So the way that would look is if you have int p, you would just set this equal to null pointer. I do want to mention though, this null pointer is only available in C++ 11 or higher. So if you're working with an older compiler, you won't be able to use null pointer. So with older compilers, you're going to need to use either the null pointer or just set it to 0. So int. So these two, the null and 0, these would be if you're using an older compiler. Or if you're working with older code. And so now let's look at how we would assign an address to a pointer. So we know how to declare a pointer now. We know how to initialize it to the null pointer, but we want to know how to assign a pointer to an address, or assign an address to a pointer. So let's say that we have int, say we have a variable called num, which is equal to 40. And then we have a pointer, so we have int, and I'm just going to call this p. And we could, when we declare this, we could set it equal to the null pointer, but I'm going to just initialize it to the address of num immediately. So how that's going to look is p is equal to ampersand. So that's assigning our pointer to the address of num. And this kind of makes sense because we have, so we've declared num, right? So we have an integer called num. We declare our pointer, and so we have a pointer that can hold the address of an integer. And then we set our pointer equal to the address of num. So now that we know how to set the pointer equal to some address, let's see how we would use this. First of all, there's two pointer operations, and we've already kind of seen them. So the ampersand, so this is called the address of operator. So we've already seen that this allows us to access the address of various variables. And then the star is the contents of operator. And this is also called the dereferencing or indirection operator. So you'll hear this called different things, but it's the contents of operator. It's also called the dereferencing, so dereferencing or indirection operator. So let's look at some cout statements, and we're going to type some code in a minute to see how this is all actually working. But let's say that we have cout p. So this is the pointer. Remember, the pointer is holding the memory location of number. So this is going to print out the address of num. And then what if we do cout and we use this dereference or indirection operator? So what this is going to do, the reason why it's called the dereferencing operator is because it's going to allow us to get the contents, or in other words, dereference the value that we have stored in the address of the pointer. So when we cout the star p, this is going to access what we have stored in the pointer. So what do we have stored? Well, it's going to access what we have stored in the address of what that pointer is pointing to. What do we have stored in that address?
40.
Yeah, 40. So this is going to print out 40. All right, so let's look at some code now. Okay, so I'm just going to continue with what we started with here, although I might, I'm just going to do int. Let's just do int x is equal to, actually let's do num, that's better. Int num is equal to 35. And then we've already seen that we can cout the address of 35, ampersand num. So yeah, we've seen this, so let's do a new line. Now let's do, so this is a little bit review, but let's say that we want to get the size of this variable. This should be 4 bytes. We can use the size of function, and we just send it num. This returns the number of bytes for that variable. And then cout, and we can do the, let's just do the value of num. And then this is just going to be the name of the variable. So we've seen this a lot. Now let's look at how we would let's look at some specific code of assigning this address to a pointer. So let's say that we have a pointer, and the pointer needs to be the same data type as so it needs to hold the same data type as the variable that we're pointing at. So in other words, we want to assign a pointer to num, and num is an integer, so our pointer has to be an integer type. So int, and then this is going to be, I'm just going to call this pointer, and I'm going to set this equal to the null pointer initially. But then let's right away just set this pointer equal to, and if we want to set it equal to the address of num and num. So let's see what we have stored in. Let's just see out some stuff again and see what we have stored. So let's start with the value of num. Let's do 1 with the address of num. So we can, with the address of num, we can either do the ampersand num again. So we can just type the pointer's name. This is end line. And then let's get the value of num from the pointer. So we already know that we can get the value of num if we just print out num, but we can also get it by dereferencing the pointer, $ptr. All right, let's run this and see what it's doing, and then we'll see how we can change some things. All right, let's run this. Okay, so just comparing this, what we're printing out to our code, we have, so this line C out, the address is, and so this is printing out an address that's a hexadecimal, which is what we expect. Size of is 4, that's what we expect. The value of num is 35. Down here, so I'm right here, the address of num is, and notice how it's the same hexadecimal address as up here because we stored that address to our pointer. So here we're printing out this address from this line, so the address of num, or ampersand num, and then notice how we have the address down here as well, and we're printing this out by just basically we just see out the name of the pointer. And it's giving us the same address because we stored that address to the pointer. And then we have the value of num here, which is 35. And if we go to line 18 in our code, we're dereferencing the pointer here. So basically we're accessing whatever's stored in that memory location. Let's look at how we would actually change the value that we have stored in this memory location from our pointer. So we've already seen that we can access what's stored in the pointer with this dereference operator. So what if we do something like this? Let's say we access that memory location. So we dereference it. And now let's say that we set that location equal to 200. What this is going to do is change num to 200. So let's verify that. We'll just see out some stuff. So let's see out num so we can see what num is now. Put value of num. And I'm going to just specify that this is after 200 so we know which one we're talking about. And then I'm just going to see out num this time because we want to verify that we actually updated num. And then let's also do see out, and let's also print out star pointer so we can verify they should be the same thing. Do star. All right, and then this is just going to be star pointer. So here we are on this line. We've printed out num, and the value is 200 now. And also, so this line that I have highlighted is 22, so value of num, and then we're couting num, and then 23, value of pointer is 200. So if we dereference, well, the value that is stored in the memory location that pointer is pointing at is 200.